Hello, everybody, and welcome to today's webinar presentation, Open Source APM for an Event Management Web Application, brought to you by Influx Data. I'd like to introduce you to our presenters. Our first presenter is Richard Duknavorian. Richard is a managing partner at IT Squared, a software and professional services firm focused on post-implementation consulting and value realization for leading APM software and solutions. Prior to that, he was the SVP for performance management at PointRight, the leading provider of cloud-based analytics for long-term and post-acute care. Our next presenter is Alex Kozlov. Alex is a hands-on technical evangelist at Riverbed with over 20 years of experience as an enterprise architect focusing on IT analytics, APM, and dynamic software architectures. Prior to Riverbed, Alex worked as a senior IT architect at Gartner, where he was responsible for IT analytics and APM for the portfolio of internal applications. And now, with that, I'd like to pass things over to you all to begin the presentation.
Excellent, thank you. Thank you for this opportunity to speak today, and thank you for that lovely introduction. So this is Richard Duknavorian speaking, and I'm sure eventually you'll be able to tell the difference in my voice and Alex's voice. But we're really happy to be working with our partners in Flux Data today to be talking about some specific use cases around applying open source APM technology for an event management web application that we worked on. We've already gave you a little bit of an update and insight into IT Squared, but essentially, as we mentioned, we focus on sort of value realization for visibility in modern web applications with a specific focus on open source as part of our core consulting practice. We've got a pretty interesting use case that I think we're going to present to you today. This use case centers around one of our clients, which was a global research and advisory firm, kind of considered to be the largest industry operator in terms of IT consulting and IT advice. Before us, we had a pretty significant challenge in helping this firm to support some of their largest event opportunities that they have throughout the year. What they were specifically looking for was making sure that the registration experience and the overall web browsing experience using their event applications, as well as their content applications, were as completely smooth and hassle-free as they could be. And you can imagine that this is no easy feat when most of your attendees at these events are some of the largest CIOs within the industry, as well as some significant IT leadership teams. So to tackle that, we needed a solution that could handle a high number of registrations and also could handle continuous user interaction online. So folks were continuously interacting with the event management application throughout the duration of the event. And it was both a sort of web online application as well as a mobile application. So clearly the striking requirement that we had was the ability to manage a very high activity load during the duration of this conference. So we had a few questions that we were trying to answer as we worked through this particular use case. One was, would it be possible to have a complex APM tool be easily leveraged by business and executive users? Something that would give them near real-time visibility, something that would allow them to look at a dashboard, see that an indicator has gone red, and be able to ask a question. We also needed to think about what were the key performance metrics and dashboards that we could create using InfluxDB, and also Grafana for the visualizations to ensure a really great customer experience. So we wanted to understand how we could create a dashboard to create a really great user and customer experience, and then also how we could apply time series in an effort to monitor the entire application stack. So we'll talk through that, but everything from the server all the way through to the presentation layer. And then also the health of each transaction that we were working with. in terms of why Influx was an important partner in this conversation for us, was really kind of detailed out on this slide, but really I'll focus first on the open source piece. We really wanted to use open source based ingestion, as well as open source log and event storage and search engine with Elastic, and then an open series, time series database store, of course, in this case being InfluxDB. And really why that was so we could have the appropriate and the necessary functionality and solution that we needed without the burden of licensing costs. Secondly, we wanted a performance monitoring tool that was simple to set up, easy to use, and very user-friendly. We wanted to have something that was easily consumable, and what we mean by intuitive, meaning that you did not have to have specialist training in APM applications in order to be able to take advantage of these dashboards, in order to take advantage of these visualizations. We think we achieved that. We think we achieved something that is very easily consumable by a number of different personas. As well as wanted to be able to do advanced time series analysis, and that is so easily enabled by InfluxDB technology. And then probably the most interesting thing that we were able to do was kind of set up an opportunity for a user to do one click, and within one click switch from monitoring to root cause analysis and troubleshooting. So a little bit about the actual solution. It is a cloud native integration for Riverbed application performance monitoring. Basically, the integration ingests app internal metrics and delays right into InfluxDB. Then you can analyze that data using native dashboards within Grafana or Chronograph, and look to unlock the data that is already stored in more complex APM tools such as AppInternals. And the solution also allows you to kind of automatically uncover insights that really lie at the intersection of all of the various data that you're collecting about the systems, about the applications, and also about end users. Really what we were hoping for was a term that we've coined in terms of intelligence response. So we felt that we were doing our job and being most successful when the integration provided troubleshooting assistance through visualizations, through time series analyses, time shifting analyses, as well as adaptive baselines. And we'll go through each of this through the demonstration. We really wanted to integrate at the UI level, meaning having contextual drawdowns into appropriate APM applications. So that's sort of that one click that I was talking about before, from the visualization Grafana dashboard into the application performance monitoring tools. We were wanted to be able to understand if there was an opportunity to predict service health and provide, that really precious lead time that you need before an SLA is broken, and do this really with machine learning based system degradation alignment. And then lastly, be able to integrate with different notification channels, so that as part of your alerting or as part of your notification process, whether it be ServiceNow, Slack, or anything else that you're using, that the system and the cloud native integration that we built also provided that notification as well. So really, it's sort of a multi-part, solution that in the end makes for a very intelligent response for a variety of different personas that will interact with the application and the integration. So speaking of the personas, really what we had here were those that were non-APM specialists, those that were site reliability engineers, as well as executive leadership. And we'll talk a little bit about the different needs associated with each of those personas and where the opportunity for the integration really kind of hit the mark there. So this was thinking about someone who is not an APM specialist, someone who is not intimately familiar with APM tools. How could we provide an intuitive response to some questions that they had. And really with intuitive, we mean it doesn't require any in-depth learning of an APM tool or its associated technologies. So it's just simple questions like, what does our performance look like today as opposed to what it looked like yesterday? Is the performance better? Is the performance worse? Is it within normal boundaries? And overall, where should I be concerned? And then how do I unlock the data that's already stored in a very sophisticated APM tool? How do I rise that data up to a level that I can see it? For the site reliability engineer, the goal was to give the SRE teams the tools and the data that they needed in order to have the most valuable experience that they could have with their application monitoring solutions. As we mentioned earlier, was there a way that an SRE team could switch from monitoring to root cause analysis and troubleshooting with just one click of a mouse? And then how could an SRE take advantage of some of the time series as part of their troubleshooting activities? And for our executive personas, how could we provide them with a snapshot view into different performance analysis without requiring really any knowledge of any industry-specific application performance monitoring tools, whether they be commercial or open source? And could powerful drill downs and powerful visualizations into focused dashboards be produced that were very predefined and very preset and specifically tailored for that executive audience? And then the last question that we wanted to answer for our executive leaders was how they also could take advantage of time series analysis and also be able to use it as part of a use case, working with the SRE team, but then also have something that was very accessible to executive leadership as well. And I'm actually going to turn this over to Alex Kozloff for a moment to talk a little bit about the different architecture that we developed specifically for this tool.
Sure. Thank you, Richard. So basically, the most fundamental component of our architecture is an APM tool, Riverbed APM, called AppInternals. It's available both on-premise and as a service in the cloud. And it's an agent-based architecture. Basically, we feed individual agents that instrument JVMs, Node.js, .NET, and various polyglot languages. They feed three types of data: metrics, packets, and traces, distributed traces, into Riverbed APM analytical engine. We turn a lot of data to produce meaningful insights targeted toward people familiar with the code and code level design patterns, meaning developers, very technical SREs, and DevOps. The representation in analysis that we do is a little bit too complex to be used effectively without special background. Our experience has been that when monitoring or operations teams needed to do a deep dive, they would also bring on the conference call or in the war room somebody with an APM background or very deep insight into code level, application code level. So that's architecturally and functionally the strength and at the same time limitations of APM type tools. So for the integration with InfluxDB, we went cloud native route. We have developed a couple of containers, packaged as containers, functionality that would pull metric time series data out of Riverbed APM and would feed into InfluxDB, enriching it with additional metadata, such as tags, if we're talking about cloud environment, server names, IP addresses, other information, if we're talking about on-premises deployment. So all in all, we have the way the deployment works. You can deploy it on Kubernetes cluster in the Fargate serverless type scenario or Docker Swarm, depending on whatever you're using. So it's very agnostic. You deploy the container that continuously pulls the data from Riverbed APM, metrics and events, and stores them in the InfluxDB database. Now, next component is visualizations in Grafana that use InfluxDB plugin to pull the data directly. So there has been quite a bit of intelligence built in and sophisticated queries and background processes on the InfluxDB side to summarize the data to produce statistical baselines, do various calculations about dynamic ranges of valid ranges for the metrics, which you'll see in the dashboards. So really use the statistical power and the data processing power on InfluxDB to be able to offer functionality. And one of the key use cases that Richard mentioned that we needed to implement was being able to pivot with one click from monitoring dashboards, analytical dashboards in Grafana into contextually rich dashboards in AppInternals APM. What it means is that if I'm in the Grafana and I'm looking at a particular time range, let's say 1 to 2 p.m. yesterday, and I'm looking at a particular JVM or microservice and filter by some other criteria. When I drill down into monitoring, let's say into exceptions, I want to analyze exceptions, or I want to analyze response time of transactions passing through that microservice. When I do a single click into AppInternals, I want to be able to have my view already pre-selected and pre-filtered by all the filters and all the metadata that I started with in Grafana. So in order to implement it, obviously the URL navigation in AppInternals speaks one language, Grafana filtering speaks another language. So we've implemented a simple container-based microservice that would do a translation and would offer a redirect, which worked seamlessly in Grafana and brought us over into AppInternals UI. In a nutshell, that's it. Richard, back to you.
Great, thank you, Alex. That's really helpful, and clearly you can see that it was really important for us to take advantage of a container-based deployment here and really keep everything within a cloud-based architecture. So let me move now to the demonstration. So I think this is hopefully what everybody's been waiting to get to. So we can stop with the slides and start with the software. So let me see if I can successfully maneuver this with our, and switch here. And hopefully now you are able to see a dashboard in Grafana. It looks that way. So I'm going to keep talking until I hear otherwise. Essentially, we're going to start here with an application monitoring dashboard that we built. We have two applications, as I mentioned before in the slides. We have our content delivery app, which was the application that event attendees were using to download different content from the industry servers to their either their mobile devices or within their own laptops. And then there's the event registration app, which again, like I said, was really the heartbeat of the event, right? This is where everybody was, signing up for things, downloading their schedule, making changes to their schedule, so on and so forth. So really, this landing page is designed to allow you to get an overall health and sort of historical performance of each of these areas. So kind of starting on the left and moving over to the right, it really starts with visualizing an application and why that's important, right? Kind of begins with some very classic or sort of golden monitoring signals. So you can see the widgets dedicated to load. You can see the widgets dedicated to server time, EUE, AppDex, as well as exceptions. And really with the exception trends, we don't even need to know where the exceptions are. But if there are exceptions and there's more of them, then likely they may need our attention and we can drill into them. Looking over to the honeycomb on the far right-hand side, we know that applications are very complex systems that consist of many moving parts. And we really wanted to have something here that was very intuitive and allowed for the user to look at the health of each transaction just by looking at the honeycomb. Just by being able to look and see if any part of the honeycomb was red, immediately they could understand potentially which of any of those transactions needed immediate attention. So whether it was a transaction associated with group registration or event information or user profiling, if that honeycomb is red, it's a transaction that needs attention, and they can drill right into that. So let me just quickly change our time here to something that's a little bit more in the past. And here we can see some interesting things happening in terms of exception trends. So we can kind of see some high activity here, then it kind of bottoms out and starts up again. But this is sort of normal in terms of the usage of both the content delivery app and the event registration app. So people are using it a lot during the actual event, but then in the evenings they're using it less. Got a little bit of a spike here, and then it kind of normals out as well. But let's start to look at some of the dashboards that are part of this solution as well, not just this one sort of classic landing page. So the first one that I want to look at is the application details. So here I'm actually going to drill in specifically to each of the applications that we have under monitoring. Excuse me. So across here, we've got various different lanes of information that we can look at. We've got the summary, which is basically just a repeat of what we had on the large dashboard. We've got some time series analytics. We've also got some adaptive baselining and also some time shift analytics. And let's kind of go through these one by each, if you will. On the time series analytics, we're able to look at different exceptions that happened here. So I can see I've got an exception happening here and here, and then it kind of flattens out towards the end there. With the time series, I can change my resolution. I can change my resolution to something that is very granular, as it is today, as it is here within a minute. I can also bring that up into a higher level of resolution. So let's say within an hour, and I can start to see some of the changes in terms of the time series analytics when I change those resolutions from very, very granular to a little bit less granular. On the adaptive baselining, I can see that pretty much this is pretty well within the server time and the baseline. But by changing our sigma to, let's say, 3, I can start to see some changes here in terms of the volume request, the server time, and the exceptions. Give myself a little bit more visibility. And then with the time shifting, here I can take an opportunity to broaden or narrow my time shift in an effort to understand more intimately what's going on with my application. So here I can kind of look at a 12-hour time shift and see changes here between where we were now and the shift, as well as if I go back to that 1-hour time shift, something that is more in line with the volume, the server time, and the exceptions as well. From here, there's an opportunity to start to look specifically at different transactions within our application, instances, servers, and tiers. So this is really where we talked about being able to monitor the entire stack, right? From the tier to the server to the instance to the transaction, all in one. So from here, if we were to look at the transactions dashboard, we can move down into some of the individual transactions that were taking place inside of our event registration app. So we have several transactions here. We have a booking transaction, create account, event info, group registration, so on and so forth. And for each of these, we can take a look at what's happening from the instance, the transaction itself, and change our resolution as well here. Moving into the server, here we can take a look at what potentially is happening with our servers and see if there's anything that is out of the realm of what we would expect it to be in terms of memory usage or in terms of memory that's free. So here I can see I've got some red, some things that are potentially concerned. I can click through this and go into the transactions that are associated here and see that, oh, okay, during my checkout, I've actually got some high EU time of 2.6 seconds associated with my checkout. I can go and drift down further into the transaction details associated with that, and continue to kind of look to understand where potentially I've got some different delays, as well as where I may be experiencing some challenges. I think it might be interesting now to talk a little bit about the one-click resolution and the one-click sort of troubleshooting that we have down into Steel Centrals. So I'm going to actually do that here and click into our performance summary for Steel Central. So here he kind of brings up Riverbed, one click, and I can take a look at the different performances that are going on from the different transactions. And for those of you that are familiar with Steel Central, and Alex will give a demo in a few minutes, we can talk a little bit more about that. But also, one of the other areas that I wanted to show is, let me go back to our server. And into the server details. And here, there's some specifics that I think are pretty interesting around time series analysis for CPU statistics, as well as adaptive baselining, and again, time shift analyses. So with that, I'm actually going to ask Alex to talk a little bit about how Steel Central kind of integrates all into this as well.
Sure. Thanks, Richard. If I can share my screen. Show my screen. Perfect. Let me know when you can see.
You're good.
You see your screen, Alex.
Okay, great. So let me try to pick up where Richard left off. So looking at the trend of 24 hours, we have a spike in exceptions, right? So I'm going to zero in into that. The important thing, as we said, once we know that we have a problem and we want to know more, some of the drill downs are keeping us within Grafana, and some of them are bringing us deep into APM land. So let me show how I would troubleshoot the exceptions, high exception count. So we're zeroing in on exception count. We see what's going on here. So with one click, I can move into AppInternals, and I'll explain a little bit what's going on, but it brings me directly into a list of all exceptions observed in our application in the same time range, right? In the 2 hours when we had a spike, and really shows every Java exception that occurred, and shows me close to 6,000 transactions where we had Java socket timeout, networking timeout. So this tells me that there is something going on either with network performance or with the way my routing configured. And I see that this is probably cause of a lot of retries and maybe some growth in response time. So in order to understand the details on the code level, this analysis operator offers me to drill into each individual transaction, each individual user out of those almost 6,000, 5,900, to understand the additional level of details, how exactly execution of that transaction happened and where the exception occurred. I see the entire topology of a transaction, multiple services involved. I see a lot of relevant data about the user, etc. I can navigate directly to exceptions and understand where they occurred and what slowdowns it resulted in. So I see that all in all, transaction response time was still pretty good, but there are a few methods, dispatch servlet and policy validation, etc., where the slowdowns have occurred. So this is a code level detail, and by quick glance at it, you can immediately say that it does require specialized skill and a little bit more of a background into how to view the distributed tracing data and the APM information. So starting from here, let me spend a couple of minutes talking about AppInternals and how we get all this data, because we're the only tool on the market when you really can drill down into your exceptions and see individual execution traces of every transaction. So that stems from AppInternals strategy and architecture, which means which targets collection of every trace, every end user transaction all the time. So let me pivot a little bit and show you what that entails. So in the small cloud demo environment that we have here, since that was up since July this year, we've accumulated in our big data store. We've accumulated almost 145 million, actually over 145 million individual transactions, traces, etc. So when I say that we've accumulated traces, it's not only that we've stored the timestamp when it occurred, IP address, maybe username, etc., and duration, maybe some other metrics. No, I'm talking about actually full level of details. I'm sorry for clicking so quick. Let me bring you back to this stack trace across multiple microservices. So really, my demo environment stores 145 millions of these individual transaction maps with this level of code execution detail, exceptions, SQL statements, etc. So this is tremendous amount of data, which affords tremendous power. Now, the type of analysis that we do in the application. So let me pivot to the app. So in the demo environment, I have a retail e-commerce application, sample application that runs in Azure on Kubernetes cluster. So it's completely cloud native architecture. I have a few key transactions that I define for this app, such as checkout, comparing items, updating shopping cart, etc., etc., etc. So the type of having collected these millions and millions of individual transactions allows to do a few unique types of analysis. So for instance, I can bring out the slowest methods across all the microservices, across all the transactions contributing to my latency, and start improving on duration of those to bring better user experience to my users. So in this case, an update card, I see that this is by far the slowest transaction of all in my application, and I have two contributing methods that I need to troubleshoot. Now, this is a fairly easy type of information, easy to consume. So what we're trying to do with the Grafana dashboards being high level, we afford a drill down into views like this to continue simple experience for the end user. But then when the time comes for specialized APM expertise, we're drilling down into search and are able to get a view like this, where we can look at each and every transaction and understand how it performs. Now, our application being cloud native, a very important aspect is discovery, means to understand what runs where, how many instances or copies of microservices we have running right now according to our auto scaling policy, etc. So what helps us with that is the application map. The interesting thing is AppInternals offers a deep level of analysis and different slicing and dicing of our topology. So here, this is the simplest logical view where I have a name of each individual microservice involved in processing of my application. You see I have two pods running, so that means I have two processes here. I can switch to logical servers, which allows me to group and change my picture based on various metadata, tags, and labels that our intelligent agents collect from applications under monitoring. Or I can switch to physical view, which will tell me where on which worker node in each cluster, in which pod, each of individual microservices run. And this picture updates dynamically. For instance, if I change to the last 15 minutes, picture will become different. If I switch to the last 24 hours, picture will become more complex. Why? Because we superimpose thousands and millions of individual transaction maps onto one another to get a composite picture for the past 24 hours. So this sort of analysis offers tremendous power, but requires a baseline level of knowledge. And the key that InfluxDB was able to provide us, key enablement that InfluxDB was able to provide us, is to integrate on a high level this knowledge and this information about our application performance and its anomalies into time series that can be presented in the unified single pane of glass type of view, make it available for different types of statistical analysis enabled by InfluxDB query language, and basically democratize this information, make it available for a much wider audience of users. So in a nutshell, this is it about AppInternals. I'll be happy to take questions if there are any about the product toward the end. Back to you, Richard.
Awesome, thanks Alex so much for providing us with that overview of AppInternals, and you can see why it was so important for us to have such an advanced APM tool, but you can also see, because of the complexity that's associated with it, that it's not an easy thing to learn, and really, when we had a couple of different primary use cases here, again, of the executive user, of the non-APM specialist, it was important for us to have, to Alex's point, that kind of single pane of glass that allowed for our users to be able to move very quickly and confidently within the higher level visualizations if they wanted to, but if they had the expertise in the APM solutions and the knowledge associated with those APM solutions, they could do that one-click drill down directly into a very powerful tool like AppDynamics and be able to take advantage of all that that tool has to offer as well. So with that, I'm going to switch back to the PowerPoint, but just kind of to talk a little bit about the real benefits that we feel were achieved through the use of Grafana, our cloud native integration from IT Squared, Influx Data, as well as Riverbed AppInternals. And that was really to allow folks to become much easier users and more efficient with their AppInternals data. Not just the application itself, but the data that it captured, and become much more efficient with utilizing AppInternals data in that single pane of glass view. We wanted and believe we achieved a benefit of, oh, I think I'm paused again. Sorry, I'm not sure why that keeps doing that. There we go. Okay, sorry about that. So I'll just back up for a second. The opportunity to become more efficient with AppInternals, not just the application, but with all of the data that that AppInternals collects. The second was being able to do quick analysis and changes. For example, narrowing the sigma, as you saw me do, so that you could most efficiently and effectively evaluate information at the time series level. And really, that was why Influx was such an important piece of this puzzle. And as well, being able to specify time and a set of activities for an SRE to evaluate very easily. And then lastly, we feel there was a strong benefit achieved by allowing non-technical business users to easily see where things are potentially going wrong, where things are moving out of bounds, with use of the visualizations like the classic golden monitoring signals that we had in load, EUE, server time, ACTX, etc. But then also the honeycomb and the ability to kind of have a quick visualization into the health of each and every transaction. So that brings us to a little bit about 20 before the hour, I think. So I think at this time, we're ready for folks to potentially ask any questions that they might have of Alex or myself.
Great, thank you both so much. We do have a few questions that have come in. The first question that we have is, how did you determine what metrics to put into InfluxDB? There seems like there are so many things to look at.
Maybe I can take that. So yeah, two things. First of all, when we undertook this integration and visualization project, we already had quite a few years of experience in the APM field. So developed best practice for ourselves, our team, our organization, but also we knew our applications. The next thing is integration being so flexible and InfluxDB being so adaptable, as things evolved, we were changing data set and modernizing dashboards to tailor to specific to specifics of application architecture. So that's number one. Number two is we have a big road ahead of us, because as our applications adopt more and more components that implement patterns of observability, our metric set is it starts to grow pretty much exponentially. So again, we'll be observing which of these observability metrics are good indicators of anomalies and change in system state, and we'll be adding them to our dashboards and statistical analysis that we're performing inside of InfluxDB. I hope this answers the question.
Yes, great. The next question that we have is, Kubernetes is such a dynamic environment. How does this integration help to address with what service or application is the problem?
So this is a great question. It starts with two things. Again, I guess. So first of all, first concept is dynamic discovery. So what's important is that monitoring agent of AppInternals that monitors application being deployed in any kind of containerized environment, that being cloud found. And by the way, Kubernetes by far is the most popular and kind of orchestrator du jour, but by far not the only way to deploy dynamic and use dynamic architectures, right? So besides Kubernetes, we use Cloud Foundry, there is OpenShift. There are organizations that are having good success with using a Docker Swarm, etc. So it's a very wide field. The key is a discovery. The good thing about Kubernetes in particular, and the rest of these infrastructure platform tools, is that they have a rich system of eventing, which inform us when changes in the deployment occur. A new service being deployed, auto scaling changes number of nodes, right, and pods per implementing service, etc., etc., etc. So real red agent that knows about this type of variability, this type of observability afforded by Kubernetes and other orchestration systems, and collects this data, adapts dynamically. Now, another important pattern that best DevOps teams use is, as part of CI/CD process, they enrich every deployment to Kubernetes with additional metadata, such as application name, what type of environment, whether it's production, a canary deployment, lower type of environment, etc. What version number of particular service in an application. So we collect all this data, and with InfluxDB, we can dynamically filter and tailor our dashboard. So as environment changes, actually number of servers, number of containers, number of instances on the dashboards will change dynamically. So as the time, and the same thing on AppInternals side. So both stay in sync, right? As I showed earlier, our application map with the time will change to adequately reflect what's actually running in Kubernetes. So the answer is discovery and having tag and label based filtering and UI built out so that we can automatically pick up new stuff as it comes online and changes. All right.
Great, thank you so much, Alex. And also, looks like we only have a couple questions left. So audience, if you do have any more questions, please post them into the questions panel. The next question that we have is, how do you integrate full stack monitoring with distributed tracing?
So what worked for us, it's context, right? So I'll give you an example. One of the leading ways to extract standard metrics and custom metrics, again, following the observability pattern that is the dominant way for various open source components, etc. These metrics, the good thing is that these metrics are enriched with metadata. right? So we for every metric, we have a context. Now, for every trace, AppInternals agent enriches every trace, every transaction execution with similar level of metadata. So the match, the join, the match, the composition, the correlation, if you will, works pretty seamless. Now, the next thing is but the biggest, I guess, we think the discovery is not actually the most complex piece of the puzzle. It requires more of a discipline from release standpoint, and DevOps teams standardize of how they deploy application, how they publish metadata with each deployment. We think that the bigger problem is the actual amount of data. Some industry research shows that cloud-native applications produce about 15 to 20 times number of metrics, time series, metadata, events, etc., about their state than a traditional multi-tier or monolithic apps. So that there is no way to fit it all on the screen. So the emphasis is going to be on turning metrics and trace data into meaningful events. And this is where analytical processing of InfluxDB played a very important role for us, starting with a dynamic adjustable baseline, through the ability to apply different sigmas to the valid interval or normal range of metrics to test hypotheses about root cause events or root cause anomalies versus symptoms, and to help arrive in a more automated fashion to the root cause and the proper way to remediate it. And the next thing is we're looking at ways to automate remediation and integrate it into our event discovery process, because the applications become more complex. Instead of tens or dozens of different components and pieces, now it's hundreds or even thousands of containers, pods, and various managed services that we're using. All right. I think that's all I have to say on this.
Great. Thank you again, Alex. So the last question that we currently have is, what do you use for root cause analysis, metrics, logs, and tracing?
Okay, so I guess we're talking about our organization, right? So InfluxDB worked wonders for us for time series data set and in advanced statistical analysis for it. So that's where we keep it. Traces obviously reside in AppInternals, and as you saw, we developed a very seamless way of traversing user interface from one to another, from one tool to another. For the logs and events, we are using Elastic, which is first of all, very well scales very well horizontally, good about keeping historic data, and also has a variety of ways of ingesting, right? Now, the important thing is alerting capabilities that allow us to bring it all together and reduce the number of events about anomalies and detected anomalies and variabilities in the system performance into a single stream. So basically what we're doing right now, we're working on turning multiple IT events into a single episode, always accompanied information about what we think are the likely root cause or root causes are, and which events we classify as symptoms. So on the technology level, as I mentioned, we use 3 platforms: InfluxData for metrics, Elastic for logs and events, and obviously AppInternals to collect traces and metrics about the application specifically. We use Elastic searches and other mechanisms built into it to group, to reduce the number of events and reduce event storm into some reasonable episodes with likely root causes and symptoms. That's our technology stack, and that's our approach today.
Great, thank you so much, Alex. And that does look like all the questions we do have. So Alex or Richard, is there anything you would like to add before we close things out?
I'd just like to add a big thank you to the Influx marketing and events team for helping us with the organization and the production of this webinar, as well as having an amazing tool that we could use to, as Alex said, perform the really complex statistical analysis we need within adaptive baselining and thresholding and be able to do constant comparisons. It was truly an excellent opportunity for us to take advantage of some great technology, and it became a really important component of what we were doing overall. So thanks to Influx for helping us with this project as well as with this webinar today.
And what I wanted to say is that me and my team were consistently impressed by the quality and performance of Influx data platform and flexibility. So starting out, we had a little bit of anxiety, obviously, of putting our most critical function of visibility and IT analytics on open source tools, but it's been a great journey. We're very happy with the results, and I'm very impressed with how quickly InfluxDB is evolving, adopting new features and helping us to come out with new ways of and new use cases to implement and bring more value to our customers. So it's been great. Thank you.
Great. And I'd like to thank both Richard and Alex for a great presentation today. And I would also like to thank Influx Data for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you further your developer career. Have a great day, and we'll see you next time.